So welcome everyone to the session Functional Reactive User Interfaces in the Modern Web Platform by Dario Mannu. We are glad Dario can join us today. Without further delay, over to you, Dario.
Thank you. Time to talk about JavaScript a little bit. So warm up, I'm going to talk fast. There's plenty of things to talk about and barely any time to cover or scratch the surface of most of it. So what we're talking about now is essentially three things. So one, the word is broken. We knew that, but fine. Two, can we fix it somehow? And three, how do we fix it in practice? Using FRP. So one key concept we're going to talk about this in this session is reactive streams, especially with regards to the UI. So we can think of nearly everything as event streams. You can think of mouse clicks, mouse movements, window openings, closings, boxes moving around, etc. Anything that happens on a page is an event source. Then you can create a little box of things like this, which processes these events one by one through some transformations, and the output goes into sinks, effects, and anything you can imagine. So why is the word broken? What's going on? First, okay, so what is FRP, Functional Reactive Programming? For those that might not. Is functional programming applied to event streams, essentially? So rather than treating arrays as functors, objects as functors, etc., we take event streams, as discussed earlier, as such, and we do transformations on them. In even simpler terms, it's just the functional way of doing reactive programming. Why is it important? Well, size, number one, in the JavaScript world, weight and size is really important, and having 50% less code is a reality, especially as applications grow. And QA, quality, so there's actually so much less to test, because if you code everything as map, reduce steps, you don't test, you don't map, you don't test, reduce. These are all concepts that are just ready for use. Maintenance, again, there's a little story, by the way. Some AI people say, oh, my AI can create 100,000 lines of code in half a second, as if there was a good thing. But actually, think about that. You are left with 100,000 lines of code to maintain, and that is an issue. So I would rather brag on an AI that creates the same application in 1,000 lines of code rather than 100,000. And I think that should be the focus, and functional reactive programming is the way to get there, I would say. Yeah, maintenance, since we do reactive streams, as we're going to see in a moment, state is normally embedded in it. So whenever you move state and everything, so it's really harder to break. One of the major issues, I would say, that make FRP difficult in the JavaScript world is what we call this last mile problem. The same as the word is borrowed from the world of telecommunications, where the last mile of your cables, the internet cables, is normally the weakest one, the most problematic. And here's the same thing. You can have a really nice, well done, well structured, beautifully created and crafted reactive stream with all the steps, but the last bit that connects to the real world, the DOM, the page, etc., or the way you source the events, is the problematic part. We'll see why. Number one is certainly side effects. So if you look at any tutorial which talks you through how to create reactive streams, etc., you always end up having to touch event sources and side effects. We know that we should avoid or limit the access to those, or isolate side effects as much as we can. Many frameworks, because in the world of JavaScript you talk about, and we work with frameworks a lot, we have to somehow interact with them, but many make it difficult. So we see stuff like these a lot of the time, unfortunately, in many frameworks. yeah, the stock, Angular, React, etc. If you've never seen patterns like this, don't even learn. Is really evil. These sort of things create also memory leaks, etc. So what we should really focus is create reactive streams and have systems that can handle the rest for us. This is even worse. So subscribing from one stream to feed another is absolute terrible things. Paradigm translations is the other problem. So many platforms. So sorry. Frameworks use this concept of signals, and what you do when you do have observable streams, reactive streams, you have to translate from one paradigm to the other, so from functional to imperative, essentially. The previous one was a React example, this is a Svelte example, so many of them are affected by this issue. This is the concept of signals, is what I would say is the imperative like equivalent of reactivity. And the problem here is you create this sort of pseudo reactive value, which is not reactive, but frameworks make you pretend they are reactive, and a set value to change it. So if you create a kind of derived variable, which is a proper variable, you would have a value as you would expect. Then you change the source, right? You would expect nothing to happen, so derived would be 1, right, as you expected. But the problem is the black magic that happens in the templates, right? So most other things are treated as if you were reactive, and through various means they have different behavior than what the syntax of the language would suggest. There are side effects and other problems as a result. Like you can't do a number of things. You can't do async functions which connect to WebSockets and wait maybe for an API stuff. So break your component in half, or like stop and wait, and then return stuff later, which will have to update, etc. Try doing this with many frameworks, you will have lots of issues. Each of them has their own ways to overcome them. So I would say, as a summary, a common issue of various frameworks is this lack of sound, explicit, monadic, Turing-complete template and the reactivity system. They all came with their own, and some were really done in a couple of minutes on the fly, and clearly the issues came up as time passed. So the verdict, I would say, yeah, is inconvenience. The major problem is the switch between imperative, function, imperative. So the frameworks give you an imperative, mostly imperative interface to interact with. If you want to use reactive streams, you have to convert back and forth, and yeah, that's really a an issue. But it's not like caused by the fact that framework authors are evil or bad or something. There is a root cause of all this, and I would say, and it's not even evil thing itself, is just the nature of HTML. So if you look at that, everything is a static string. So an input with a value is a string, a class is a string, CSS color is a string, etc. So the only dynamic thing here in HTML is this on-click handler kind of thing, which has always been like that. You can add a function, but that's not really enough, I would say. Okay, so how can we change all this? Can we? I would say with these two guys, observable and observe interface. Not sure how familiar you guys with these patterns. Please raise hands if it's very new to you. I'll try to slow a bit down because the third part of this session is going to be the most technical one. So observable is the interface which enables true reactivity. This is a reactive primitive as opposed to signals. You can subscribe in order to get updates, and you pass an observer to this observable in order to get notifications. You can do that by either passing a simple function like this, or an observer object, sorry, with next arrow complete, to get a more fine-grained control over the data stream. It's going to be the fastest crash course on RxJS I've ever seen, because of time. So RxJS is the most popular stream management, reactive stream management library. I assume you're familiar with the promise. So promise is a simple monadic continuation-like thing. You got some operators, then all promise settled, etc. issue with promise it can only resolve once, but if you're on the UI, you have a button, you click it 10 times, the promise is no good because it can't emit 10 times. So observables come to the rescue. Observables can emit as many times as you like, infinite number of times. There are mainly three types of, in RxJS. The pure observable is a read-only thing. Then you have subject and behavior subject, which are read-write streams essentially, and these are key elements to functional reactive programming. We'll see why in a moment. The most interesting part of observables is they got plenty of operators, high level, really well studied operators. There's about 200. But don't worry too much because most of the times in real life you lose up to kind of 15, I would say. And if you need to use the 16th, the 17th, ChatGPT and friends are there for you. So yeah, is essentially this filter map, switch map tabs. There's plenty, but these are kind of the most common. Yeah, of course, this is very short, too short, but that's what it is. RxJS is the first, one of the first ones, and certainly the most popular such library. They came into the JavaScript scene. This is what the original format was like. So to create a stream, you create a subject, you do .map, .reduce, and everything. This format has changed, and in different implementations, because of lack of standardization, the language is not always the same. So the current one is like this. So you import each individual operator you want to use, and you pass them as functions this way. So this is the current way we use JS. It's a bit confusing, I know, but such is life, unfortunately. This is the forthcoming version of Rx, which is going to be slightly different. So you got this Rx function that you pass one operator or entity one by one, and the like. We talk about standardization. Finally, there is now something moving on. This time is supported by incubated by the W3C. And this thing works in Chrome now, so you can already use this today. So when you do document.when click, that's an equivalent of add event listener, but returns an observable. So you can do .map, .subscribe, .filter, etc. Natively, just the original RxJS syntax. So all this stuff works now. You can use it. The problem with this is the current proposal is still bare bones, so hardly even usable in a proper large-scale application. So there's a lot of monkey patching to do and things. We'll see in a bit. Okay, so we've seen how static HTML is. We've seen observable streams. We've seen standardization moving on forward. What if HTML itself was functional reactive by nature? How about maybe the value of an input which just supported the stream? What if the class of a div was a stream? What if the CSS color was a reactive stream? Data attributes, custom attributes, the content, and on the other way around as well, event handlers could feed reactive streams directly like this. Well, turns out there's a way. A little library with this exact purpose. So making HTML look like everything was a stream and supporting streams directly. So all this made in practice. So you create an observable stream in various means. By the way, RxJS is not the only one that can be used. There are other libraries like Most, Bacon, and Kefir, and others. But yeah. So this is the idea. You can go further. You can use the component. The component is a really practical, useful design pattern. It's monadic as well, by the way. If somebody didn't think of it, this is unique function. Composition itself is like the bind. It's similar to what other frameworks do. So you keep the stream and the state. So state is a stream in this case, all right? So we try not to use just constant as bad as we can, but the value here is using streams whenever you have to connect an input to an output. Okay, so let's see this in practice and sort of things that can happen when HTML becomes all observable. So this is a little bit of a model of a basic starter example. So the click counter component, right, is the hello world of reactivity. You got a button, you click it, and it counts it, right? So you connect this yellow thing. This is your view model, this observable stream, which does it. The code is really simple. This is it. All right. So the count is this behavior subject is the stream. 0 is initial value, scan is just the counter, is the RX lingo for fold. And then after that you have this, RML is the tag, the template for to make all this work, and you connect on click as an input of the stream, and the span out count is the output of the same count. And remember, this is a proper reactive primitive, essentially. And all Rimmel does is essentially bind input and output to the stream, to the DOM. So yeah, event sources to the left, data sinks to the right. Essentially, anything on something is treated as a source. So you can feed any event stream, any reactive stream with this, and all these syntaxes are valid in order to make to sync streams back into the DOM. So what does everything as a stream mean? Yeah, literally data, state, views, mount, timers, even dialog boxes. This to the right is an example of a dialog box as a stream. So you have a message event from a stream. You connect to this component. It shows your message. OK, and cancel will be reactive streams. Cancel does pretty much nothing in this case, just closes the dialog box. And if you press OK, it will emit an OK stream, and then you can take any further action. So composition, galop, form submissions, lots of other things. Separation of concerns, sorry. In some more complex components, you can do things like isolate your reactive streams away, have your collection of models, view models or something, and you can pass them into your components, right? Just naturally. Like this, yeah. In many other frameworks, you just can't do that, because you have to, follow the rules. Like inside the component, you have to use this, use that, use state, etc. You can't take out. In Rimmel, this is plain JavaScript, literally. All right, so it's as close to vanilla as you can think of, right? You can do all these things. The components can be async. You can stop in the middle. You can do plenty of things, and it all works. One interesting pattern that has emerged working with this for a while is event adapters. So the idea is that your reactive streams should be UI agnostic as much as possible. So you might have a stream of strings to numbers, or strings to strings, date objects to other things, etc. But whenever an event is emitted from the DOM, it is a DOM event that you get, right? So if you have multiple data sources, each with a different format, what you do is this: you use this event adapter. So essentially, you got this, in this case, an input, a text field. So on the onChange event, you emit the value of the same input rather than an event object. So this is your observable stream, right? It is a stream of strings. So it takes strings and it doesn't care where they come from, right? So it's a very neat separation of concerns you do, and it's plenty of these adapters that can make life really useful. The other interesting pattern that emerged is pipes versus reverse pipes. Not many people know that in RX you have this pipe function in addition to the pipe method. So the idea is you create a pipeline, right? So if you create a pipe like this, you pass some operators, filter, map, etc. That becomes something you can feed with the stream, right? So when you call to uppercase stream, right, you pass another stream to it, like a subject, a behavior subject. Then it becomes an equivalent of stream dot filter dot map, etc. And then you can subscribe, etc. But in order to make the previous thing happen, like these event adapters, what you really need is the opposite. So rather than appending operators to the output of a stream, as you've done here to the left, you prepend the operators at the beginning, at the input of a stream. So this is why I call this reverse stream or input stream, input pipe, and you do it like this. So essentially, create, you call input pipe, you pass the operators you want to be used, and this is essentially how you use it. So it creates a new stream you can feed, and it makes sure you've got these operators applied. When your application start to grow a little bit, you will not necessarily want to just deal with simple values, but with something more advanced, complicated, repeated arrays of objects, etc. So we create this thing, observable types, which essentially is array, JavaScript array, plus observable plus observer. So it's a reactive array handler essentially, created just to do things like this. So this is an ideal component with a list, which will send self-rendering list. You got an input item which will feed its own value whenever you change it. So you just type something, you hit enter or click away, it will immediately call this array.push and append the item to the end, and is rendering aware. So whenever you call array.push, array.pop, it knows the best way, the most effective way to make these changes to the DOM. By the way, there are links to the right here. Feel free to screenshot to have a look. There are examples illustrating all these things in more detail. You can play on them. So this is the code for a simple example. So we can create a collection of strings, in this case, a really simple one. And this is our template. So this list, we are using this HTML list, which means don't just dump the data as it is, but treat it as this clever list, reactive list. And this is how we feed. Cut is another event adapter. So essentially cuts the content of this input box and feeds your stream with the value of the input, right? So whenever you type something, you hit enter, it will clear the box and feed your list. And yeah, you can call all other methods of this array and treat it as array. So a button just to remove the last one. There's lots of other things. You can have a look at this link and play. Essentially, can everything array can do, this can do. If you have more complicated or real life objects, you can do collections of objects. This is one, okay, first name, last name. You can create a template for your item in a totally custom way, right? It's like two boxes by the same code, just to try to fit this the available space. And then in your actual template, you use this collection sync, in which you declare that for the data, which is this collection, you want to use your custom template, so each one will be rendered the way you specify. And yeah, this is essentially again a whole stream and behaves just like all other streams. Mixins are another really interesting thing. So this syntax is used essentially to merge anything that comes out of this function into the target element, right? So drag and drop is one little thing you can do in order to isolate functionality and make it reusable in a functional reactive way. So draggable, yeah, in this case, essentially internally has its own stream of things. And the key thing that happens here is we, return an object of mergeable properties. I call them attributes. So things like are going to be attributes later. So this sets a class to be draggable on this div, sets an on mouse down handler, which will be this DND stream, and style will actually set the style of this div through the output of the same stream. Okay, so this draggable, yeah, again creates internally a stream which essentially takes your pointer events, transforms them into coordinates, transforms them into CSS transform, and stops doing this when you do mouse up. So this essentially is the various steps you take to do drag and drop. This is the code available. Yeah, I can't really go through everything. It's a couple of more lines, but essentially this is the core, and it's really, really short and effective. there's a little more advanced version of this, making it async, right? So a little box here. This is the slightly more advanced version of it. You need to click this button inside the box in order to make it draggable, right? So the idea is you take a trigger, the button will be the trigger, the click. Draggable takes that, and whenever that emits through this syntax, you can make the draggable emit later, right? So these mixins can behave in an async way. One way we can use them is for example admin login. So you have a web app with some content. You got a login button. When you log in and you are recognized as an admin, all components that can be editable will become editable by way of deferred, delayed async mixins without you having to re-render the page. So just new attributes come into the page. Right. Quick, tiny little example. Tic-tac-toe in 35 lines of code, if you look at that. This is one key part of it. So let's look. So row just goes through lines, cells, etc. A cell is a bit like this. You got your template button with data attributes X and Y. On click, you feed a stream of X and Y clicks through dataset object, which is an event adapter again. So this dataset object essentially takes all the data attributes of the current source, in which case X and Y, will merge them into an object and will feed this reactive stream, click streams X and Y. And then there are other things like disabled. So a button on the grid becomes disabled as soon as either the game is over or when the cell content has been set. So once you click on a cell and you play it, essentially becomes disabled. So you can't click it twice. Merge is an RxJS for to take two different streams, one after the other, and whichever emits forward, essentially. And this is the cell content. So you get that just a second. So whatever you have clicked, it will be displayed as the content of this button. So the X or the O. Cell content, it comes from an external array of click streams and just essentially displays the player you want to have. Code is a little bit longer, but we tried to show how concise all this can be. Okay, so one little word we mentioned native observables, right? They are a bit interesting because the way they are defined at the moment is like you really it's really hard to put them into any UI library or framework because it is a truly functional reactive thing, and the biggest issue is that you only have this observable when you call document.when or any event.when, element.when click, for example. Yeah, it gives you an observable, but normally when you're working with any UI library or framework, you don't have this observable yet, right? You only have that after rendering. So we came up with this thing, it's observable, observature. So observable plus future, let's call it for now, observature. Or just stream, future stream. So essentially what this thing does is treat a future observable that doesn't exist yet and call methods, instance methods on it. Behind the scenes is a proxy. So you can see how it works. Is interesting, but we'll see how things evolve because all this is really new stuff. It's temporary. Things might evolve a little bit. We'll see how the committee evolves. So this is what enables a library to work with native observables. This example here on the page, you can have a look. This is a pretty simple example, but it makes end-to-end use of native DOM JavaScript observables to do things. Unfortunately, like I said, the proposal is still very minimal. So some essential operators like even scan, fold in other terms, is missing. So what you do is you monkey patch those, or you do something creative about that. This is what they expect, but of course, many people are not really happy with with this way, because it's very dangerous. Well, not very dangerous, but quite dangerous to monkey patch globals. So yeah, and the rest works the same. So in your template, you bind the same stream as RxJS streams. The only difference is in this case you don't use RxJS but native observables. Right. So in summary, what we've been talking about, number one is, functional reactive programming is a bit challenging to do with modern name frameworks, where we talk about React, Angular, but even others like Svelte, Vue, etc. Because the imperative paradigm is the number one thing. All of them focus on, and you might be aware there is a proposal to get signals standardized as well, because most of these frameworks concentrate, at least use signals, and for them, of course, it makes sense to standardize that. But on the other hand, we have observables being standardized as well. Is just going through a more challenging path, because initially it was a TC39 proposal. There has been lots of pushbacks and reworks, etc. So the proposal has been kind of abandoned. Then a second attempt happened in the WhatWug, but that's been kind of left there as well. Now there's a third push. Is mostly done by some people in Google Chrome team, and is going through the W3C web platform. So if that happens and goes through, it's quite likely that it will land in Node.js as well. And once it's both in the web platform and Node.js, the idea is that that will mean there's enough momentum for like more standardized recognition and adoption of the observable as a primitive in JavaScript. So in order to make functional reactive programming end to end, so from event sources to data sinks, a great way is to pretend HTML itself is functional reactive, as we've seen. At the moment there's not too many libraries that can do it. Rimmel is probably one of the first ones that does it and treat HTML as such, and make observables as first-class citizens. You can use promises as well the same way. So when you can put an observable, you can put a promise. The only difference is that promises are not like as simply read-write as observables. If you want to see some more stuff in here, this is what everything is. If you want to get involved in some open source fun, I've been involved in this for 3 years, nearly 4, conception to everything has been used in large platform things, but also in small tiny projects alike, because it is scalable. So there are two really scalable, strongly scalable elements of all this, and those are essentially the observable streams, which are monads on their own, so they give you crazy good scalability. But if you use components as well, which got very similar properties, you got the best of both worlds to in terms of composability, quality, and etc. So I managed to go really fast. My first attempt was much longer. So if are there any questions or something? So I know I went really fast. I'm pretty sure I confused pretty much everyone. But if there are questions, happy to go through them quickly now. We're gonna have a hangout session afterwards. So I'm happy to go into details, any sort of crazy questions you might have.
Yeah, thanks, Dario. I don't think it was too fast. I guess the pace was right. And hopefully, thankfully we have finished it on time only. Before time, we would say. So yeah, if anyone of the attendees have any questions, doubts, queries, anything, you can put it in the chat or Q&A section, and Dario can try to answer it.
Yeah, there are libraries who tried to implement observables somehow, but Angular is one. So Angular has been claiming for years, yeah, we support observables, etc. And look at what they're doing now. They're turning to signals, so like literally it's 180 degrees turn. And yeah, it's a bit unfortunate because they miss out. So by not using observables, what happens is like your code becomes longer, like it or not, and if you start mixing these two paradigms, observable streams with signals, conversion back and forth, the problem is you have to start managing unsubscriptions. So in the Angular word is quite known expression, always unsubscribe, like you are really responsible for these things, otherwise memory leaks and all these things. This way, you don't have to worry about that. You just create your streams, you bind them, and you don't even touch subscribe. So it was on purpose that I didn't show how to subscribe, how to call subscribe in Rimmel. Most of the times you don't even do subscribe at all because the library does it for you. So and does all the unsubscriptions as well. So everything is handled. All the side effects are handled behind the scenes for you.
Okay, I guess nobody has any question. So if you
So
have any question, we can have it in the Hangout section. So yeah, once again, thanks Dario for sharing your experience with us.